Hello and welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for chemistry for the year 2015. This is the first part of the recording where we are going to look at the first 20 questions. If you are new to this channel, please don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at scholarf.com to practice the UTME exam and modular quizzes for free. The first question here is on matter. Which of the following statements is correct? That is the first statement. The average kinetic energy of a gas is directly proportional to its temperature. Okay. The greater the temperature, what this implies is that the greater the temperature of a body, the greater the average kinetic energy of the particles of that body. So the greater the temperature of a gas, the greater the kinetic energy, the average kinetic energy of the particles of the gas. The reason why we use the average kinetic energy is because the particles of that gas, they move at varying speed, so they have different kinetic energy. But overall, okay, the average kinetic energy of the particle is going to increase with an increase in temperature, and it will decrease with a decrease in temperature. Okay. If you explore the other options here, at constant temperature the volume of a gas increases as pressure increases. This is wrong. Okay, this is wrong. According to Boyle's law, okay, at a constant temperature the volume of a given mass of gas is going to reduce. It will vary inversely as the pressure, meaning it will reduce as the pressure increases, okay, or the volume increases as the pressure decreases. So this is wrong. And here that the pressure of a gas is inversely proportional to its volume. This would have been correct if the condition, if this condition is added, that is at a constant temperature. This condition has to be there. And here the temperature of a gas is directly proportional to its volume. This would also have been correct if the condition that the pressure of that gas is kept constant is added to it. This would have been the Charles law. Okay, if that condition is added to it, while this will have been the Boyle's law if the condition of a constant temperature is added to it. So basically here the correct answer here is the first option that we have here. The average kinetic energy of a gas is directly proportional to its temperature. As a matter of fact, we can also say that the temperature is a measure of the average kinetic energy of the particles of a body. Next question on organic chemistry. What are the correct Iupac name for these compounds here? So this compound here has the functional groups like COO. Alright, that is the functional group of the esters, that is the alkanoate. So that means that this compound here is an alkanoate. Okay, so which alkanoate is it? Then we now look at the substituent that we have there. Alright, this one that we have here is methyl methanoate. Okay, methyl, starting with this last substituent here. Okay, this last allyl or alkyl group here, that's CH3 for methyl. So methyl methanoate. Now this is supposed to be CH3. Okay, it's supposed to be CH3. However, as it's the case with esters like that, H here means methyl. Okay, CH3 will mean ethyl. So if this was CH3, we will say this is methyl ethanoate. Okay, but H, okay, is methyl. Alright, H is methyl here. So this is methyl methanoate. While this compound that contains 3 bonds, that has 3 bonds, is an alkyne. You can tell it's an alkyne. Alright, and it has 2 carbon atoms. 2 carbon atom, that's eth. 1 carbon atom is met, 2 is eth. So this is going to be ethyne. Okay, so we have methyl methanoate and eth. Next, on qualitative analysis, a solution X on mixing with silver nitrate solution gives a white precipitate soluble in ammonia. A solution Y, when added to X, to this solution X, also gives a white precipitate which is soluble on boiling. Okay, solution Y contains, the solution Y contains lead ion. Okay, the solution Y contains lead ion. That is the solution that we added to this solution that gives this reaction with ammonium nitrate. Okay, the solution Y that will be added to it, that will give this reaction, that is, that will give a wet precipitate which is going to be soluble, that is, that would dissolve on boiling. Okay, would contain lead ion. Methane is a member of the homologous series called, alright, the surface here, that is the last figure that I have here, okay, tells the homologous series to which that compound belong. Okay, members of the alkane, their names end with ene, like for example ethene, prop 1 in, so it ends with ene. For the alcohols, it ends with oh, like the alkanols. Okay, it ends with oh. The esters, those are the alkanoates, they only have that functional group of COO. And basically that's why it's not even about the functional group, it's about the name. Okay, their name will end with noate, like methyl ethanoate in the methyl methanoate in the first question that we took. But here, okay, if you can see the last the suffix here is ane, okay, which is the suffix for the members of the alkanes. Okay, the members of the alkanes, they end with their names in the end with ane, like methane. This methane is the first member of the alkane group. After methane we have ethane, then we have propane, butane, pentane, hexane, like that. So basically the names is going to end with ane, this suffix. Which of the following bonds exist in crystalline ammonium chloride? In ammonium chloride we have three bonds. Covalent bond, okay, the covalent bond is between the nitrogen and the hydrogen in the ammonia. Then we have coordinate covalent or dative bond between the ammonia, okay, and hydrogen ion, okay, that is in this ammonium ion. All right, then we have ionic bond between the ammonium ion and chlorine. So here we are going to have ionic, okay, we have ionic bond, we have coordinate covalent bond and coordinate covalent bond. Next question. Some copper 2 sulfate pentahydrate was heated at 120 degrees Celsius with the following results. The weight of the crucible is 10.0 gram. The weight of the crucible and the copper sulfate pentahydrate is 14.998 gram. The weight of the crucible plus the residue is 13.54 gram. How many molecules of water crystallization was lost? And here we have the atomic masses of the hydrogen, copper, oxygen, and sulfur. Alright, so here the copper pentahydrate, alright, this is the chemical formula. Let the number of moles of the water of crystallization that is lost, let it be X. Okay, now in the original substance here, the copper 2 sulfate pentahydrate, there are 5 moles of water in it. Alright, now if you represent the number of moles of water of crystallization that is lost as X, then the number of moles of water of like the remaining water of crystallization is going to be the 5 here minus the X that is lost. Okay, now when we decompose, if this when this was heated, when the substance was heated, okay, it decomposed into copper with a reduced water of crystallization. Okay, so we still have the copper sulfate, however the water of crystallization has reduced. Okay, some of it has been lost. Okay, so we have, so I represented the number of moles of the water that was lost as X. So we are going to have X number of moles of water here, in addition to the remaining from here is going to be 5 minus this X. Okay, now the weight of the crucible from the question is 10 gram. The weight of the crucible and the original hydrate here, the copper 2 sulfate pentahydrate, is 14.98 gram. The weight of the crucible plus the residue is 13.54. So the weight of this copper 2 pentahydrate only is going to be, we subtract this from the residue. Alright, we subtract this from what we have here. So you have 14.98 minus 10. Okay, that is to get to get the weight of the copper 2 sulfate pentahydrate. Okay, we are going to subtract the weight of the crucible from the weight of the crucible and that copper 2 pentahydrate. So we have 14.98 grams minus 10, and that is 4.98 gram. So this is the weight of that copper let us say of this substance here. Let me denote this substance as A, okay, to avoid having to repeat the names. Okay, so let's say the weight of A only is going to be this 4.98 gram. Now let's find the molar mass of A. That will be the sum of the atomic masses of the atoms that we have here. So you have copper plus sulfur plus 4 of oxygen plus 5 of H2O, 5 of all of what you have here. So you have copper, that's 63.5 plus 32, okay, plus 4 times the atomic mass of oxygen, which is 16, plus 5 times, we look for the atomic mass of this substance here, that is the water, H2O. So in the water we have 2 of hydrogen plus 1 of oxygen. So you have 2 times the atomic mass of hydrogen, which is 1, times 1, that is 2, plus the atomic mass of oxygen, which is 16. By the time we evaluate all of this, we'll be getting 249.5 gram. So that means that 1 mole of this substance A is equal to 249.5 gram. Okay, so X moles is now going to be this. I just want to know what is the number of moles of this substance A that we have in this. Okay, so you just say let X moles of this be equal to that mass that we have. Then we are going to set up a ratio, alright, using both sides of the equation. So you say 1 over X here is equal to 249.5 over 4.98. Alright, if we cross multiply, you are going to use the denominator to multiply the numerator here, and the denominator here to multiply the numerator here. So you have 1 times 4.98 is equal to 249.5 times X, okay, as we have it here, and this will become 249.5X, while this is 1 times 4.98. To get the value of X here, we are going to divide both sides by 249.5, and that will give us 0.02 moles. So that means there's 2 moles of this substance A, okay, in this, okay, 2 moles of it was produced here. Now, so the number of moles of the substance A that is heated was 0.02, right, 0.02 moles. Now, using the molar ratio from this equation of reaction here, okay, from this equation of reaction here, we are going to have 1 mole of this substance here, okay, this substance A produced, let me say this is substance B now, okay, we have another substance here, alright, let me say that is B, let that be B. So 1 mole of this substance A produce 1 mole of this substance B, okay. 0.02 moles of this substance will then produce 0.02 moles, since they have the same number of mole, okay. The number of mole of this substance A here is 1, the number of mole of this substance B here is 1, okay. So we say 1 mole of this will produce 1 mole of this, as we have from this equation. So 0.02 moles will also produce 0.02 moles. Alright, now the mass of the residue only, okay, the mass of the residue only is going to be, this is the mass of the crucible and residue, okay, but this is the, I mean, let me say weight or mass, okay, weight or mass. This is actually mass because this is in grams, okay. But let's say weight, the weight of the crucible plus the residue is 13.54, while the weight of the crucible only is 10.0 gram. So we subtract this from this to get the mass of the residue only, okay. So you have 13.54 minus 10, and that is 3.54. So 0.2 moles of this substance is equal to 3.54. Now, next thing we're going to do is calculate the molar mass of this substance here. That will be the sum of the atomic masses of the elements that we have here. So we have the atomic mass of copper 63.5 plus sulfur 32 plus 4 times 16, that's of oxygen, plus they are going to have 5 minus X times whatever we have here, okay, for this water. And the molar mass of water is this 2 plus 16, that is 2 times 1 of hydrogen plus 16 of oxygen. So you have 18 right here. Okay, if you evaluate all of this, you'll be getting this times and this plus this is 18, so 18, okay. But this one on this side first, before we get here, what we have here, if you evaluate it, you will get 159.5, then plus this 18 here times this 5 minus X. If you open the bracket here, you're going to have 18 times 5, which is 90, 18 times minus X, that will be minus 18X. Then you have 159.5 plus 90, and that will give 249.5 minus 18X. If we then set up a ratio, alright, we would say that is 0.2 moles of this, okay, is 0.2 mole of this is equal to this 3.54. So 1 mole of it, 1 mole of this in there, which is the molar mass, okay, the molar mass of this substance means the mass of 1 mole of it. So you say 1 mole of this is equal to what we have here. Then when you cross multiply, this denominator here will multiply the numerator here, and you have 1 multiplying this here, right? So we have 0.02 times what we have here is equal to 1 times 3.54. If you open the bracket here, you'll be getting 0.02 times this, that is 4.99, and is 0.02 times 18x. That will be, minus 18x. So this will be minus 0.36x. This is then equal to 1 times 3.54 is 3.54. Then we collect the like times. Alright, so we bring this to this side and we bring this to this side. Alright, because this is a number independent of x, this is also a number independent of x, so we bring them together and we just bring this one that has x to the other side. I'm bringing this one to this side for convenience, because I know that when this minus 0.36x comes to this side, it will become plus. Alright, and that is easy to deal with. So I'm going to have 4.99 minus 3.54, that is equal to 0.3x. This minus this is 1.45 equals 0.36x. We then divide both sides by 0.36 to get the value of x. So we have x to be equal to 4. That means that 4 moles, okay, of the water oxidation was lost. It means that the remaining substance is not going to be copper, okay, tetraoxosulfate or copper 2 sulfate, then that's a monohydrate, okay, because 4 moles of this has been lost. Next question: which of the curves shown above represents the relationship between volume and pressure of an ideal gas at constant temperature? Alright, so according to Boyle's law, okay, the pressure and the volume of an ideal gas, okay, varies inversely. Alright, varies inversely. That means that if you have a graph of volume against pressure, then the graph is going to slope like this. However, if you look at this graph, this is a graph of volume against the inverse of the pressure. We can state down below in two ways. We can say that the volume varies inversely as the pressure, or that the volume varies directly as the inverse of the pressure. Okay, so if that is the case, then it is going to be a straight line graph. Alright, we are going to have V varies directly as the inverse of the pressure, so it's going to be a straight line graph, okay, sloping upward from left to right. So that will be this graph, the graph here. Okay, it is going to be this graph here. Alright, the graph of pressure against the inverse in the volume, or the graph of volume against the inverse in the pressure. So it's going to be a straight line graph. Next, on acid, base and salt: 12.0 gram of a mixture of potassium carbonate and potassium chloride was dissolved in 250 standard flask. 25 cm cube of this solution requires 40.0 cm cube of 0.1 mole per dm cube hydrochloric acid for neutralization. What is the percentage by weight of the potassium carbonate in the mixture? You have the atomic masses of the potassium, oxygen and carbon. Alright, so this here is going to be a case of an acid base reaction, alright, between the carbonate and the acid. Alright, now when a carbonate, okay, that is a triazocarbonate, when it reacts an acid, a salt, water and carbon dioxide is formed. So this will be the equation of reaction between this potassium carbonate and the hydrochloric acid. Alright, so we have a neutralization reaction here. Now from this reaction, if you look at the number of moles of the acid to the base, we see it is 1, okay, to 2. Okay, it is 1 to 2. That is, we have 1 mole of this base reacting with 2 moles of the acid here. Okay, 1 mole of the base reacts with 2 moles of the acid. So we are going to have the number of moles of the acid is 2 here. The number of moles of the base of the carbonate, as the case is here, is 1. Then we use our the formula. From the formula we have concentration of acid times the volume of acid over the concentration of the base times the volume of the base is equal to the number of moles of the acid over number of moles of the base. And already we have some of this information from the question. The concentration of the acid we are given here as 0.1 mole per dm cube. The volume of the acid here is 40 cm cube. We have 40 cm cube of the hydrochloric acid. That is the volume of the acid. 40 cm cube, we convert it to dm cube. Alright, because this is a mole per dm cube, there's dm cube here, so our unit needs to balance. To do that, we divide this by 1000 and we have 0.04 dm cube. Okay, the concentration of the base we don't know. Okay, we don't know that yet. The volume of the base is 25.0 cm cube. Alright, we convert this to dm cube by dividing by 1000. We have a 0.025 dm cube. Alright, so we call this formula here. Okay, we call this formula here, and then substitute these values that we have here. So we substitute all the values that we have except for the question of the base, which is what we are looking for. 1 times is 0.04 divided by the question of the base times 0.025 equals the number of mole of the acid, which is 2, over number of mole of the base, which is 1. If you cross multiply, okay, this one is going to multiply this here, this denominator here on this side will multiply the numerator on this side, while this denominator will multiply the numerator on this side. So this cross multiplies, and we have 1 times is 0.1 times 1 times 1 times 0.04, okay, is equal to, and on this side we are going to have 2 times the expression of the base times 0.025. okay, that's what we have. So here we are going to have is 0.04 equals this times this is 0.50. Then when we divide both sides by 0.5, we'll be getting is 0.8, okay, mole per dm cube. Excuse me, 0.04 divided by 0.5, that is 0.08 mole per dm cube. Now, okay, so this is the concentration of the base. We will now calculate for the molar mass of the carbonates, okay, the carbonates here. That will be the sum of the atomic masses of the elements that we have here, of the atoms of the elements that we have here. So we have 2 of potassium plus 1 of carbon plus 3 of oxygen. This will be 2 times the molar mass of, or the atomic mass of potassium, which is 39, plus 12 plus 3 times the atomic mass of oxygen, which is 16. When we evaluate this, we'll be getting 138 grams per mole. Okay, now the mass concentration, okay, would then be equal to the concentration times the molar mass. Okay, the concentration times the molar mass. So the mass concentration is going to be the concentration, which is 0.08 mole per dm cube here, times the molar mass, which is 138 gram. So here we have 11.04 gram per dm cube. Okay, so but the mass of the mixture, okay, from the question is 12.0 gram. Okay, so we want to know what is the percentage of this triazocarbonate that is in this mixture. So that will be equal to the mass concentration of this triazocarbonate, which is 11.04, divided by the mass of the mixture, okay, which is 12. Then multiply this by 100. So this divided by 12 will give us 0.92 times 100. We are going to have 92%. Next question on periodic table: which of the following groups of physical properties increase from left to right of the periodic table? Alright, the ionization energy is the energy that is required to remove the valence electron, a valence electron. Okay, now what happens is, as you go from left to right in the periodic table, you are moving from group 1 to group 2 to group 3. Now as you're doing that, the number of valence electron is increasing from 1 to 2 to 3. So as it is increasing, it will take more energy to remove those valence electrons because of an increase in the force of attraction between the proton in the nucleus and the electron. Because as they are moving across the group, more protons and electrons are added to that, to that atom. So there will be a greater increase in the force of attraction between the electrons in the shell or the orbit and the proton in the nucleus. So the ionization energy is going to increase from left to right. Alright, fine. Now another thing that I should explain under this is that as there's an increase, okay, in the force of attraction, it means that that atom is going to become smaller. It's going to be shrinking because now the proton is pulling the electron to itself, like to the center, with more force. So the atom is going to be getting small, and as it is getting smaller, the atomic radius, okay, which is half the distance between two covalently bonded atoms, okay, two covalently bonded atom of the same element, okay, that atomic radius is going to be reducing. So this one is out, okay, it is out. The next thing is what we call electronegativity, okay, electronegativity. Now as you go from left to right across the periodic table, you are moving from electropositive element to electronegative element, okay. So the electronegativity is increasing. The group 1 element, they are the most electropositive. then followed by the group 2, followed by the group 3, then from group 4 you are getting to the electronegative element. So electronegativity increases. Okay, electron affinity is the tendency to accept electron, the tendency to accept electron. Just like electronegativity, it also increases from left to right until you get to, it stopped at the halogen. Okay, it stops at the halogen. The noble gases, they have the least, the least electron affinity because of the octet structure that they possess. Okay, but these two here, they also increase from left to right of the periodic table. So we have 1, 3 and 4. We have 1, 3 and 4. These properties, they increase progressively across the period. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post UTME exam. It also features modular quizzes in physics, chemistry and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next question: what are the possible oscillation numbers for an element if its atomic number is 17? To determine that, we need to write the Kml configuration of the element. So this is going to be, for this element with an atomic of 17, the Kml configuration is going to be 287. Now this element here has 7 electrons in its outermost shell. It can either, so for it to attain octet structure, okay, octet structure means for it to have 8 electrons in its outermost shell, it can either donate this 7, like remove this 7 so that it has this 8 here, or it can accept one more electron so that this will now become 8. So it's either it donates, okay, it donates. Alright, if it donates, that means it's now going to have, like plus 7. Alright, it will become plus 7, meaning it will have more positive charge than negative charge. Let's leave it at that. It will become plus 7, and if it accepts one electron, it's going to become minus. Okay, it will become minus 1. So the original number of this atom here is going to be minus 7 and minus 1. However, this atom here, of course, is an halogen. It is an halogen in that it has 7 valence electron, and that means that in the periodic table it's going to be in the group 7, which is the group for the halogens. This an atom has a greater tendency to accept electron. Okay, it has a greater tendency to accept electron than to donate electron. How many valence electrons are contained in the elements represented by? This is phosphorus with the atomic number of 15 and atomic mass of 31. What we call the valence electron are the electrons in the outermost shell, okay, of the atom. How do we determine that? We need to first write the Kml configuration of this atom first, okay, and to write the configuration we need the atomic number, which is this subscript that we have here, that is 15. The atomic number is the number of proton in the nucleus of the atom, the number of proton in the nucleus of the atom. Okay, so in this case it is 15. Now this number of proton is also equal to the number of neutron, provided that that atom is electrically neutral, meaning that provided that that atom has not donated some of its electrons or accepted any electron. So it will have equal number of proton and neutron. So that means that this atom has 15 proton and 15 neutron. So we now write the Kml configuration, that is 285. Okay, if you sum up this now, you're going to get this 15 here. Alright, so you have 285. Why do you have 285? Is that the first shell, the K shell, can only take 2 electrons. The second shell, the L shell, can only take 8 electrons. Alright, then the next shell, that is the M shell. Now in that M shell we have 5 electrons. That M shell is the outermost shell here. Okay, that is one that is on the outside. Okay, and so we have 5 electrons on it. So that means that this element has 5 electrons in its outermost shell. Okay, the last number here, when you write an element in it using the Kml configuration, the last number here gives you the number of electrons that it has in its outermost shell, and in this case that is 5. Alright, an element Z, it contains 90% of 16 of this isotope here and 10% of this. Its relative atomic mass is, alright, to get the relative atomic mass, you can see that here the atomic number is the same thing. Alright, That's because this element is an isotopic element. Okay, it is an isotopic element. Isotopic elements, they have the same atomic number, which is this subscript here, but they are going to have different atomic mass. Okay, so how do we now find the relative atomic number? You take that percentage composition of the atomic mass, the sum of the percentage composition of the various atomic mass that it has. So that means we are going to take 90% of 16 plus 10% of 18. Okay, so you have 90% of 16, and that is 90% is 90 over 100, which will be 0.9. 0.9 times 16 will give us 14.4. That is that. Then plus 10% of 18. Okay, 10% of this 18 here. That 10% is 10 over 100. That will be 0.1 times 18, which is 1.8. So we have 14.4 from here plus 1.8 here, and that will be equal to 16.2, which will be the the relative atomic mass of the element Z here. Next, a quantity of air was passed through a weighted amount of alkaline pyrogalol. An increase in the weight of the pyrogalol will result from the absorption of. So air is a mixture of various gases. Okay, all of these gases are present in air: nitrogen, neon, argon, oxygen. We also have some other noble gases and carbon dioxide. Now, when you pass air, okay, through this, all right, through alkaline pyrogalol, the alkaline pyrogalol is going to absorb the oxygen. Okay, it's going to absorb the oxygen in that mixture of air, in that mixture of gas, in that air. All right, so the increase in the weight of the pyrogalol will be as a result of the oxygen that it has absorbed. Okay, the oxygen that it has absorbed, that is what will account for the increase, okay, the change in weight of the pyrogalol. Water for town supply is chlorinated to make it free from. So chlorination is one of the processes involved in the supply of water to towns or homes for domestic use, and that is the addition of chlorine to the water, and that is for disinfection, to make it free from bacteria and other harmful microbes. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2 or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, it could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below. Next question on acid base and salt. 4.0 gram of sodium hydroxide in 250 cm cube of solution contains. Looking at the options that we have here, they are in mole per dm cube. That means that in this question we want to find the concentration of the sodium hydroxide. So to do that, we are going to find first, we need to find the number of moles, okay, of the sodium hydroxide that is in this 4.0 grams of sodium hydroxide. The number of mole is going to be the given mass here, which is 4.0, divided by the molar mass. So you need to calculate the molar mass of this sodium hydroxide. Sodium hydroxide, this is the chemical formula NaOH. The molar mass is going to be the sum of the masses of the atomic masses of the atoms that you have here. So you have sodium plus oxygen plus hydrogen, the atomic masses 23 plus 16 plus 1, and this is 40 grams. Okay, that is the molar mass of sodium hydroxide. The number of moles now is going to be the given mass, okay, which is 4.0, divided by the molar mass, which is 40. So we have 4 divided by 40, and that is 0.1 moles. So this is the number of moles. We will then go and use the formula for concentration. The concentration is equal to the number of moles divided by the volume. However, if you look at this unit here, it is in moles per dm cube, but the volume that they give us in the question is in cm cube, so we will convert that to dm cube. So convert from cm cube to dm cube, we divide by 1000. So you have 250 divided by 1000, and that is 0.25 dm cube. We can now use this formula for concentration. Okay, so the concentration is equal to the number of moles of the sodium hydroxide, which is 0.1 here, divided by the volume, which is 0.5. Okay, So you have 0.1 divided by 0.5, and this will be 0.4 moles per dm3. Next, on environmental pollution, a major effect of oil pollution in coastal waters is the oil pollution leads to destruction of marine life. Okay, that is the spilling of crude oil, okay, in water. It can disturb the life or the activity of the aquatic organism, the plants and animals in the water, okay, in the aquatic habitat. So one of the major effects of oil pollution spillage is the destruction of marine. In general, an increase in temperature increases the solubility of a solute in water, because so what happens is an increase in temperature is going to increase the average kinetic energy of the particles of the solute, and that will lead to more collision. That is, more solute molecules are going to collide with each other, because now there will be increased kinetic energy, so they are going to have more or greater collision, all right, between the molecules of the solute and the solvent. So dissolution, okay, is going to be faster, all right. So there's going to be increased solubility, meaning the substance is going to be more soluble. You notice this if you try to dissolve, let's say, maybe tea, for example. Maybe could be the regular tea, for example, like the Lipton, or the other ones like Milo. Okay, you notice that when you dissolve it in hot water, it is faster. Okay, it will dissolve faster, like it will mix. There will be the diffusion, the rate of diffusion in that solvent, in that water, is going to be faster with an hot water than with the cold water. That is due to the increase in the average kinetic, the increase in the average kinetic energy of the particles of that tea, okay, that you are trying to dissolve. All right, last question here. The relatively high boiling point of alkanols are due to, it is due to the hydrogen bond. Okay, the hydrogen bond in the alkanols, and alkanols are a group of organic alcohols. Okay, it is responsible for their high boiling points. Okay, we have a question on acid, base, and salts. Given that 15 cm cube of sulfuric acid was required to completely neutralize 25.00 cm cube of 0.125 mole per dm cube caustic soda, sodium hydroxide, calculate the molar concentration of the acid solution. Okay, we have to find the concentration of the acid solution. Okay, so first we are going to write the equation of reaction. Okay, the equation for the reaction between the sulfuric acid and the sodium hydroxide, and that is what we have here. Now you can see from the reaction here, from this equation of reaction here, that 1 mole of the sulfuric acid, okay, combined with 2 moles of the sodium hydroxide to form 1 mole of sodium sulfate and 2 moles of water. What we actually need is the number of moles of the acid and the base here. So the number of mole of the acid here is 1, the number of mole of the base here is 2. Then from the question, we have the volume of the acid as 15.0 cm cube. Alright, the volume of the base is 25.00 cm cube. They give us the concentration of the base as 0.125 mole. We have to find the concentration of the acid. So we will recall this formula here, that the ratio of the number of mole of the acid to number of the base is equal to concentration of the acid times the volume of the acid ratio the concentration of the base times the volume of the base. Then we substitute these values that we have from here. So for the ratio of number of moles of acid to base, we have 1 to 2. Okay, 1 to 2. So this is equal to the concentration of the acid times the volume of the acid, which is 15, ratio concentration of the base times the volume of the base. 15 times this is 15 Ca, and this time this is 3.125. Here we have 1:2. 1:2 means 1 over 2, and 15 Ca ratio, this means 15 Ca over 3.125. If you cross multiply here, it means the denominator here is going to multiply the numerator here. The denominator here will multiply the numerator here. So you are going to have 1 times 3.125 is equal to 15.60 Ca times 2. Okay, by the time we multiply this, 1 times this, we get 3.125. 15.0 times 2, we have 30 Ca. To get the value of the Ca, the concentration of the acid here, we will divide both sides by 30, and and so you have our Ca to be equal to 0.104 m. Okay, that is capital M here, meaning the mole per dm cube. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at ScholarFedu. Okay, like and share our content, and visit our website at scholar.com to practice UTM exam and modular quizzes for free. Thank you.